Hi, it's Mr. Anderson, and today I'm going to be talking about electricity and electric circuits. Scientists have known about electricity for a long time. In fact, the word actually comes from the word amber, because they realized that you could rub amber, which is essentially dried out sap, with fur, and you can generate a static charge. If you've ever gone down one of these new plastic slides, you've come out with a lot of static electricity. What is static electricity? Well, let me show you. Here I've got I don't have a balloon, but I have a rubber glove, and so I've blown it up. And if I rub this on my head over and over and over, you can actually start to hear static electricity building up. And what it's doing is it's actually pulling electrons off of my hair, and it's putting those electrons on this balloon. What's left in my hair? Well, there's less electrons, and so my hair now has a positive charge, and this has a negative charge. But it's not going anywhere; it's sitting there, so we call that static electricity. And so the reason this kid's hair is standing up on end is that all of these strands have positive charges on it because they're missing their electrons, and like charges repel, so they're all pushing on each other, and that's why they're all pulled apart. That's why you could touch the end and get a shock. What is that? It's simply a flow of electrons. And so static electricity is where it stays in one place. But the real revolution took place when we could actually make circuits and we could control and use that electricity to do things. Before that, it was mostly steam power. And once we had the arrival of electricity, then we really had the next revolution, or this digital revolution. You probably don't think about it all the time, but our whole society now is run by electricity. So if you search something in Google, you don't realize this, but you're consuming energy at that point because you're making a search, and so Google has to go search through their database for that quote-unquote answer. And so they use a huge amount of energy. It's one of their big costs. And so they try to make their data centers as efficient as they can. They'll try to put them towards areas where they can get cheap and available energy. So how does electricity work? Well, this is not a great analogy, but it's an analogy that works fairly well, and I stick with it. And so if we have a battery like this, how does that store energy? Well, a way to think about it would be the same way that we store and move water around. And so this is a giant water tower in Finland, and so if we break apart how that works, they have underneath the ground, they have a pump, and that pump pumps water all the way up into the top, and that water is just sitting there. And so that water sitting there has a certain amount of potential energy. And in a battery, the electrons have an amount of potential energy as well. And so we call that push, or that stored energy, voltage. Okay, so let's say I want to use some of that. Let's say I turn my faucet on here in my house, or I flush the toilet here in my house. Well, we've got all that energy, and so it's going to flow in this direction. And so the flow of water through this water circuit is similar to the flow of electrons in an electric circuit. Now, this diagram's not quite complete, because what happens after that water is done? Well, we first of all have to clean it, but after we've done that, it goes right back here so that we can pump it up again. And if there's any break in that circuit, we call that an open circuit, this whole system wouldn't work. And likewise, if we ever have a break in an electric circuit, we can't move that electricity as well. And so today I just briefly want to talk about simple electric circuits and show you how electric diagrams work. There are a few symbols that you should know. The first one is the idea of a battery. On a battery, there's going to be a positive side, and so on this battery right here, the positive side is going to have that little bump on it, and then it's going to have a negative side. And so the symbol, an electric circuit for a battery, we're going to have a top, and then we're going to have a bottom like that. And then it's going to be connected with leads or wires that go out the other side. And so this is symbol for a battery. And on a battery, this is the positive end, so the wider side is going to be the positive end, and then this would be the negative end. Okay, what about a wire? Well, a wire is really simple. A wire is simply going to be a line in a circuit. Let me try to make it a little straighter than that. Sometimes lines will pass each other, and so we want to make sure we understand if those wires are connected or not. And so we usually put a dot here that represents that those two wires are connected. And so this right here would be two wires connected, so electricity could flow through it. But if you just have wires crossing each other inadvertently, we don't usually draw that dot to connect them. Okay, next thing, there are things that actually slow down the movement of electricity, and we call those resistors. And here's some resistors right here. I'll talk in a little bit more detail later. You can actually look at the color bands on it, and you can tell how much resistance there is. But a resistor is going to be anything that slows down the movement of those electrons or impedes their movement. And so the symbol for a resistor is this. It's just up and down lines, and then we have leads on either side. Okay, next we have a light bulb. A light bulb is connected, so you can actually see that electricity will flow in the bottom. So there's a little bit of metal on the bottom, and then it's going to flow out on the side. And so it's connected all the way through the light bulb through a filament, and then it goes all the way down to the bottom. And so the wire goes through it. It's high resistance wire that it goes through right here, and so it gives off a lot of heat and light. And so the way that I'll draw a light bulb to show that it's connected all the way through is to draw a loop, and then I draw the bulb around the outside. Next we've got a switch. A switch is simply an opening in the circuit. And so this would be like a light switch. And so a light switch is drawn like this. We just have a switch like that. And then if it was a closed switch, we would just have it like this. And so this would be an open switch. I try to make that a little straighter. And this would be a closed switch right here. So electricity can flow here, but it couldn't flow through here. And the reason it can't flow through here is that electricity is not able to move through the air. And so we almost call that an infinite amount of resistance. And then the last thing we have is a potentiometer. So I said that wrong, but a potentiometer works like this. We've got a variable amount of resistance. And so we've got an arrow, and then we've got a wire going out in the other direction like that. And so electricity comes through this direction, and then it goes out this direction, but we can move this back and forth so we can vary the amount of electricity that moves through it. If you've ever used a dimmer switch in your house, you've seen that a dimmer switch just looks like this. So how does that work? We're turning the amount of electricity that can move through the potentiometer, and so we're letting either more electricity or current flow or less, and so we can get more light or less. So those are the circuits. Now all I want to do is just do a little bit of practice. And I've got some pictures here. I think I've got just 3 of them. So if you want to pause and then try to sketch out what that circuit would look like, you could do that. So here we've got a simple battery, and then we've got a light bulb. So if I were to draw this, I tend to draw my circuits on the left side, or my batteries on the left side. So I'm going to draw my battery first. So this right here is the positive end. And so I'm going to draw my battery like that. Now I'm going to draw a light bulb. And then it's going to go right back to the battery. And then we put a bulb on it like that. And so this is what the electric circuit would look like. It simply has a battery here. So this would be the positive end. And then this is going to be the negative end. Electricity is going to flow through this loop, and it's going to light the bulb. And that's a closed circuit because it goes all the way in a loop, and so it can return. Next one, if we try this gets a little bit more complex. We've got a battery, and then we've got a series of lights. So let's try that. I'm going to draw my battery here on the side. So this is my battery. And I like to kind of make this as simple as I can. So this is a wire here, and a wire here. And so what we have is 3 loops. And so I'm going to draw one loop. So let's go. I'm going to go from the top to the bottom. And so this would be my first loop. That's got a switch that's actually closed. So I'm going to draw it like that. It then has a light bulb. And then it goes back to the battery. My next loop over here, we've got the same thing. So it's got a switch. It goes through the light bulb, and then it goes back. And then we've got my third loop. So my third loop goes like this. It's got an open switch. It's got a light bulb. And then it's going to go back to the battery. And so this would be a circuit diagram for that. Electricity can go all the way around. There's actually 3 pathways that it can go. You can see right here that since it's open, So since we've got an open loop right here, electricity can't go through that, so we can't have electricity going through here. So we call that a high amount of resistance. So where's the electricity have to go? It has to go through the other loops. And so let's go look if that's right. Yep, you can see that these two lights are lit because electricity is moving through it, but no electricity can pass through here. And so there's no light on at that point. But we have a continuous loop to this and a continuous loop to that. Okay, let's do the last one. Last one, this is a picture of the Arduinos, which we're actually going to use to get to in class. This has a processor over here on the side. It's got electricity coming out of here. This would be the positive end, and then this is going to be the negative end. This is called a breadboard, and so the way breadboards are connected is that there are connections horizontally. So there's a wire that connects all of these lines. And then on the side, there's going to be a wire that connects them all vertically. And so there's a wire connecting through there. And so that maybe helps to trace it. I'm going to start by drawing my battery again. So we've got our battery here. I'm going to go from the negative side. So I'm going to go from this negative side. So you can see right here, it's going to connect to a light bulb. So I'm going to do that first. So we've got a light bulb. Try to make that light bulb a little bit bigger. So now we have a light bulb. You can see that that goes through the light bulb. It goes down to the next level where we've got a resistor. So my resistor is going to look like this, like that. And then it looks like the next thing we have is a potentiometer. And so if I go like that, it's going to be a variable resistor. So it's going to be a variable resistor. And then we've got the other side with the arrow, and then it's going to connect back to my battery. So how does this circuit work? Well, you can vary the amount of resistance here, and so I would imagine in this circuit, when you turn this dial back and forth, it's going to vary the amount of electricity, and so this light is either going to get bright or it's going to get very dim. And this resistor right here is, probably the role of that is to decrease the amount of current, and so that we don't have too much electricity going through the light bulb. And so that'd be the circuit diagram for that. So again, electricity is simply the movement of electrons. In the next few podcasts, I'm going to talk in a little bit more detail about what is voltage, what is resistance, what is current, how do we quantify all those things. But the first thing you should understand is that electricity has to have a loop. It has to make it all the way back. If it's not, and it's just sitting there, it's static electricity, like in this balloon, like in my hair, and like in lightning as well. So I hope that's helpful.